Our I can statement for this video is I can read and create graphs with decimal numbers. And we've been studying about decimal numbers quite a bit, but we haven't used them in graphs just yet. Today, you'll get that chance. So you'll notice today's lesson is going to be using your workbook page, but I've changed some of the words so that it's not the same problems. You'll notice some of the typing looks different. So do not use the answers that we come up with on this video for your problems. You are going to need to do the math separately on your own workbook. As always, it's really important to read the directions so we know what we're going to be trying to do on this page. Graphs with decimal numbers, same as we've already talked about. Every year, on her birthday, Anna's parents measure her height with a meter stick. That seems important. She's using a meter stick, not a foot ruler, or a yardstick. The line graph shows her height at 4 different ages. So I see the line graph here on the right side. That tells me that it must be continuous data because they're measuring something over time. That's why we use line graphs, is to show continuous data and a change over time. Anna's age 3, age 4, age 5, age 6. So each gap here is 1 year of her life. Now I want to pay special attention to the other axis. This one says height. This is my label over here, and it says in meters. So each of these heights here is written in meters. I'm going to take a closer look at this because there's something on here that we haven't seen a lot of yet. First of all, I'm going to look at the title, Anna's height on her birthday. We kind of already knew that, but it's important to read it. And there's only one bar, so I don't need to look for the key because there's no different colors. There's only one line, sorry, it's a line graph. I see this symbol down here. I want you to notice this. Okay, it looks like a line, but then it goes jagged, and it comes back, and it comes back up. And what that means is that there's missing data in there. All right, so this is 0 right here, and this is 1 6/100. And what this symbol shows us is that not all of the data, or not all of the numbers between 0 and 1 6/100 are represented. They've taken some of them out because there are no data points that low. And if I look really closely, I can see that this distance from here to here is a change of 2 in the hundredths place, so 2/100. But that same space from the baseline to here is a change of 1 6/100. Oh yes, so that makes sense. This is the same distance from here to here, but this is 1 6/100, and this space represents 0 2/100. So yeah, obviously there's some missing numbers in here. This is not all represented, that's why they use this symbol. So let's look at the scale now, and as we already identified, that space, or it's counting from here to here by 2/100, which means each of these smaller spaces is 1/100 of a change in height, so 1/100 of a meter. That will help us identify some of the ones that don't fall right on the even hundredths marks. Let's go over now to problem number 1 and see what they're asking. Alright, number 1. How much did Anna grow between her 5th birthday and 6th birthday? Well, to answer that, I need to identify how tall was she on her 5th birthday and how tall was she on her 6th birthday, and then subtract. So on her 5th birthday, if I find her 5th birthday, age 5, and then I follow this over, I see that she was 1 14/100 meters tall. So I'd write that down. And then on her 6th birthday, she is, it's right in between 1 14/100 and 1 16/100. So this must be 1 15/100. So I'm going to write that above, 1 15/100. And they want to know how much did she grow, so how much did that change is what that's asking. And if I subtract this, I see that she grew 1/100th of a meter. So my answer on the line, how much did Anna grow between her 5th and 6th birthday? Just 1/100th of a meter, or 1/100th meters. How tall was Anna on her 3rd birthday? So I find 3rd birthday, and I go over, and I see that it's 1 8/100ths. This plot right here is how tall she was on her 3rd birthday, and this tells me how tall she was. There's my answer, and I've labeled it meters. Remember, these are not your answers. These have different questions. All right, number 3. I'm not going to answer this one all the way through, but I'll get your thinking started. Number 3. A growth spurt is a period of very fast growth. Between which 2 birthdays did Anna have a growth spurt? So your answer is going to say 2 different years, age blank and age blank. So that's what your answer is going to look like. And it says that a growth spurt is when you grow really fast, or a very fast time of growth. So it could be between ages 3 and 4. Figure out how much did she grow there. It could be between age 4 and 5. Figure out how much she grew there. Or it could be between age 5 and age 6. Figure out how much she grew there. Whichever one is the fastest growth in between 2 different years is her growth spurt. Pause the video and complete those 3 problems, and then continue with the next. I'm going to continue on. This bar graph, I don't want that. This bar graph shows the length of some common beetles. Notice we have a bar graph now because we're talking about discrete data, and discrete data means we're measuring different things. And as you can see on the bottom, we're talking about different beetles and their length in centimeters, length of common beetles. There's no change over time, so we would not use a line graph like before. What is the length of a ladybug? Well, to find that, remember this is a different word, yours is a different question, don't use my answers. Ladybug, I would find ladybug and I would go over. Oh, I see that it's in between 2 numbers, so I need to figure out what is the real answer. Well, this is 6/10 and this is 8/10. In between 6/10 and 8/10 would be 7/10 centimeters. So my answer would be 0 and 7/10 centimeters. Next one, about how many dark beetles, right here, would have to line up end to end to be about as long as a tumblebug. So I want to figure out, well, how long is a dark beetle, and how many of them would I need to put together to equal 1 tumblebug. I'm not going to do that one for you, but you can use estimation with these bar sizes, or you can figure out exactly how long are each of them and solve that way. Next, it says estimate the length of a tumblebug, right here in the white bar, in hundredths of a centimeter. Notice my scale here only goes to the 10th. This is in between 2 different tenths. So what would it be if it was closer to the 100th? Well, I want to figure out which 2 tenths is it between right now. And that line on the top, above it, is 1 and 0 tenths, and the one below it is 0 and 9 tenths. So if it's in between there, what would you estimate would be the top of that line? That would be a good estimate for how long a tumblebug actually is, to the nearest 100th of a centimeter. Notice on my line, I've set up decimal point blank blank, so it's going to go to the nearest 100th. I need to fill in all of those place values to get that to be right. And the last 2 on this page I'm not going to walk you through. I want you to give them your best shot by yourself. Our last step is actually making a graph with decimal numbers. And today we're going to focus on creating a bar graph with decimal numbers. Let's read the directions. Last year, a car dealer kept track of the portion of car buyers who bought each color of car. The box on the left shows the information. Use the box on the right to make a list that shows each number rounded to the nearest 100th. So really quickly, we're talking about a portion of car buyers. So if I added all of these up, these should add up to one whole, which would be all of the car buyers. So we're talking about a portion here, not whole numbers of people who bought cars. So it says that we need to round to the nearest hundredth. So I'm going to do the black and the blue cars for you. If I were to do this, I would write the number out for black, the portion of people who bought black cars. I would underline the hundredths place, and the thousandth place would tell me to round up or down. In this case, the thousandth place is going to tell me that I'm closer to rounding this up. So instead of 0 and 13 hundredths, we're going to 0 and 14 hundredths. So the hundredths place went up by 1. So that would be 0 and 14 hundredths. The blue cars, it says 0 and 168 thousandths. Again, I underline the hundredths place, circle the thousandths, and if it were to round down, that would stay the same, and the hundredths place would go up by 1 if it rounded up to the nearest hundredth. And in this case, yes, it does again. It rounds up. So the portion of people who bought blue cars was 17 hundredths. You have a few questions to answer afterwards, and then you will graph your data down below. Have fun!